This video is based on the paper Key Reinstallation Attacks, Forcing Nonce Reuse in wpa2, and it demonstrates how weaknesses we discovered in wpa2 can be abused to attack Android and Linux devices. First, I will use an Android device to connect to our Wi-Fi test network without an adversary being present. Notice that this network uses wpa2 encryption as indicated by the lock symbol. Additionally, when visiting for example match.com, Android will use HTTPS as an extra layer of protection. This is indicated by the green HTTPS lock and also explicitly mentioned when viewing the web page info. In other words, all transmitted information is currently protected using both wpa2 and HTTPS. Let's now start the tools that will be used to attack Android and Linux devices. First, the following command is used to start our wpa2 attack script. Notice that I included the protected Wi-Fi network that will be attacked and that we will only target one specific device. The tool starts by searching for the protected Wi-Fi network we will attack, and then it will clone this network on a different channel. This malicious clone of the network enables the attacker to reliably manipulate handshake messages, which is required to abuse the weaknesses we discovered. Second, we make sure the victim can access the internet through our malicious network. Additionally, I'm also executing the SSL strip tool. This tool will try to remove the additional HTTPS protection of improperly configured websites. Finally, I'm going to use Wireshark to capture any data that the client will be transmitting. We are now ready to carry out the attack, so let's go to the smartphone and again connect to the wpa2 protected test network. Once the victim enabled Wi-Fi, Android will search for the test network. Once it has discovered the network, it will try to connect to the real test network, which is not what we want. Fortunately, we can solve this by sending special Wi-Fi frames that command Android into switching to a different channel. This tricks Android into connecting with the malicious clone of the network. Essentially, we now have a man-in-the-middle position between the victim and the real Wi-Fi network. This allows us to reliably manipulate messages and carry out a key reinstallation attack against a four-way handshake. Normally, after executing such an attack, the victim will reuse nonsense when encrypting data frames, and this allows us to recover any encrypted data. However, due to an implementation bug, Android and Linux will not reinstall the actual secret key. Instead, they will reinstall an all-zero encryption key. This makes it trivial to intercept and manipulate all data that is transmitted by these devices. When we now go to Wireshark, we can already see that a significant amount of data was intercepted. Note that normally all this data is encrypted using wpa2 and therefore isn't readable by the attacker. However, without knowing the password of this protected Wi-Fi network, we can read all the packets that the victim is sending. This clearly demonstrates that we have successfully bypassed wpa2. Let's now visit a website on the Android device of the victim. In particular, we will again visit match.com. As you can now see, there is no longer a green HTTPS lock in the address bar of the browser. This means the website is no longer using HTTPS as an additional layer of protection. Note that we were able to bypass HTTPS using the SSL strip tool. Although this method of bypassing HTTPS does not work against properly configured websites, it does work against a significant fraction. Unfortunately, many users will not realize HTTPS is no longer used and therefore will continue to log in using their real email address and password. The attacker is now able to intercept the email address and password of the victim. Of course, this is just a demonstration using a fake account, meaning the login fails. Nevertheless, the attacker is able to see which password we try to use. So let's go to the attacker and search for the login attempt. We can see that the attacker was indeed able to intercept the username and password that the victim used. To avoid being a victim of this new attack against wpa2, you must update all of your Wi-Fi devices.